So I am Dr. B.K. Varik, a retired principal of a college. Now I will tell you regarding heat and thermodynamics. First I will tell you what is the difference between heat and temperature. Heat is a form of energy. Heat is a form of energy. There are different types of energy: light energy, sound energy, and so many energy are there. In the heat is one form of energy. This is one point. First I will tell you what is heat, then I will tell you what is the temperature and what is the difference between heat and temperature. Heat flows from, second point is, heat flows from a body at high temperature. Heat flows from a body at high temperature to a body at low temperature till there is equalization of temperature. This continues when till there is temperature same. When the temperature remains same, the heat doesn't flow. Till there is equalization of temperature. Third point is, in any exchange of heat lost by hot body is equal to heat gained by cold body. Heat lost is equal to heat gained. And similarly, fourth point is, the weight of the body remains the same whether it is heated or cooled. And fifth point is, heat is the cause. It is a scalar quantity. It is energy. Capacity of doing work is energy, and energy is a scalar, so it is a scalar quantity. And its unit is calorie or kilocalorie. So this is all regarding heat. Then what is temperature? Temperature is the thermal condition of a body. Temperature is one point is the thermal condition of a body. It measures the degree of hotness or coldness of a body. By temperature we can know whether a body is hot or cold. then it is the effect. This heat is the cause and temperature is the effect. When you apply heat, then the temperature will rise. When you take out heat, the temperature will fall. So heat is the cause and temperature is the effect. Second point is temperature is the effect. When heat is given to a body, its temperature will rise. Temperature will rise. Similarly, when heat is taken away, its temperature will fall. Then third point is temperature determines the direction of flow of heat. Always heat will flow from high temperature to low temperature. When bodies are placed in contact. There are two bodies, one is at a high temperature and other is at low temperature. If you connect the two bodies, then heat will flow from high temperature to low temperature, and direction of flow will be depending on the temperature. And when two bodies are at same temperature, there is no flow of heat. There is no flow of heat when they are in contact. As they are in contact, and then it is said to be, then two bodies are said to be in thermal equilibrium. That means if there are two bodies and they are in contact with each other and there is no flow of heat, that means the temperature of the two bodies are constant, then we say that this body, these two bodies are in thermal equilibrium. बंद हो गया था. Then thermal equilibrium is also attained ED, ATTAIN when heat flowing out of the body is equal to heat flowing heat flowing into the body. Whatever heat flows out, if it is equal to heat received by the body, then it is also called as thermal equilibrium because temperature remains constant. Then fourth point is two bodies may have same temperature, may be at same temperature, what contains different quantity of heat. So this is all regarding temperature, and that is also regarding heat. And unit of temperature is degree centigrade or Kelvin. Then I will tell you regarding different scales of temperature. To measure temperature, different scale of temperature is used. First is this is scale of temperature. First is a Celsius scale. On this scale, ice point is taken as taken as 0 degree centigrade, and steam point means boiling water is taken as 100 degree centigrade. So ice is marked as 0 degree centigrade and steam point is marked as 100 degree centigrade. Both taken at normal atmospheric pressure. Both taken at normal atmospheric pressure. That is 76 centimeter of mercury. The interval between these 2 points is divided into 100 equal parts. That means between ice point and steam point, it is divided into 100 equal parts, and each division is called as 1 degree centigrade. Each division is called 1 degree centigrade. Then Fahrenheit scale. Second is Fahrenheit Fahrenheit scale. Here ice point is marked on this scale. Ice point is marked 32 degree Fahrenheit, and steam point is marked 212 degree Fahrenheit, and the interval between these 2 points is divided into 180 equal parts. And each division is called one degree Fahrenheit. Then third is Reaumur scale. And ice point here is 0 degree Reaumur, and steam point is 80 degree Reaumur. And the interval between these 2 points, the interval between the ice point and between these 2 points is divided into 80 equal parts, and each division is called as one Reaumur. One degree Reaumur. And if so, that means Celsius scale, ice point is 0 degree, steam point is 100 degree, it is divided into 100 equal parts, and the Fahrenheit scale, ice point is 32 Fahrenheit and steam point is 212 degree Fahrenheit, and the interval between them is 180. And similarly, Reaumur scale, ice point is 0 degree, steam point is 80 degree, and interval in between them is 80 equal parts. So, if you can find a relation between Celsius scale, Fahrenheit scale, and the Reaumur scale. If Tc, temperature in a Celsius scale, Tf, temperature in Fahrenheit scale, and Tr, temperature in Reaumur scale, are the temperature measured in Celsius, Fahrenheit, and Reaumur scale. Then Tc minus 0, and it is divided by 100 equal parts, divided by 100 is equal to, so Tf minus 32, 32 is the ice point, here ice point is 0, so Tc minus 0 by 100 is equal to Tf minus 32 by it is divided into 180 equal parts, and that is also equal to TR minus 0 divided by 80. So from this relation you can find the temperature in different scale of temperature. Because I say that so you can find a relation between this and this, then Tc by 100 is equal to Tf minus 32 by 180, or that is if you divide by 220, then this becomes equal to Tc by 5 is equal to Tf minus 32 by 9, or Tc is equal to, implies Tc is equal to 5 by 9 into Tf minus 32. So if Tf is given, then you can find Tc. If say Fahrenheit scale, temperature of a Fahrenheit scale is given, so if you want to convert it into centigrade scale, then you can use this relation. Similarly, from here also you can find Tf minus 32 is equal to 9 by 5 into Tc, or Tf is equal to 9 by 5 Tc plus 32. So using this relation can be used when Fahrenheit temperature in the Fahrenheit scale is given, so you want to convert it into centigrade scale. Similarly, if centigrade scale temperature is given, then you can, using this relation, you can find the temperature in the Fahrenheit scale. Then another scale of temperature which is commonly used, that the scientific measurements can be done within this with this scale, that is called Kelvin or absolute scale of temperature. Kelvin or absolute scale of temperature. It is a standard temperature scale used for scientific measurements. It is denoted by symbol capital T. Capital T stands for a Kelvin or absolute temperature scale. The lowest possible temperature scale is called absolute zero. Absolute zero temperature, and in this absolute zero temperature, molecular motion of molecules ceases, stops, or becomes minimum. And it is denoted by symbol Kelvin. And absolute zero temperature is equivalent to absolute zero is equivalent to minus 273 degree 0.15 degree centigrade. and melting point of ice on absolute zero scale of temperature or Kelvin scale is 273.15 degree centigrade. This is zero temperature minus 273.15 degree centigrade, and the ice point, melting point of ice or ice point is taken as plus 273.15 degree centigrade. And T, temperature in the Kelvin scale, is equal to temperature in the centigrade scale plus 273.15. That means if the in centigrade scale, if temperature is centigrade scale is 0 degree ice point, then in the Kelvin scale it will be 273.15. Similarly, boiling point of water is in centigrade scale is 100 degree. So in a Kelvin scale it will be 100 plus 273.15, that is 373.15. In many cases 15.15 is neglected. It is like that, written as capital T is equal to Tc plus 273. Then I can calculate one problem is there. You can write calculate the temperature which has the same value on this Celsius and Fahrenheit scale, or at which temperature both the thermometers Celsius and Fahrenheit scale will give you the same reading. And we know that we can use this formula Tf is equal to 9 by 5 Tc plus 32. This formula you can use Tf is equal to 9 by 5 Tc plus 32. Suppose we read a temperature in the Fahrenheit scale, that becomes X. So that also will be same in the centigrade scale, that will be also equal to X. So that means using, if X is the temperature at which both the thermometers will give you the same reading, then Tf will be X and it will be also 9 pi by 5x plus 32, or this implies 9 by 5x minus x is equal to minus of 32. You can take this x to that side minus, and this is positive, it is taken out this side, so that becomes minus. So now 9 by 5 minus x is 4 x by 5 is equal to minus 32, or that is equal to 4x is equal to minus 32 into 5, or x is equal to minus 32 into 5 by 4. So that is minus 40 degree. So 40 degree in the centigrade scale will be 40 degree centigrade, and also Fahrenheit scale it will be minus 40 degree Fahrenheit. So both the thermometers will give you at minus 40 degree, both the thermometers will give you the same reading. It will give you 40 degree centigrade, minus 40 degree centigrade. Fahrenheit scale also will give you minus 40 degree centigrade, Fahrenheit. Then I will tell you regarding thermal expansion. Thermal means heat, expansion due to heat. Thermal expansion means expansion is increase, either increase length or increasing area or increasing volume because of heat. Expansion due to heat. When a body is heated, it expands length expands, breadth expands, and height also expands. So volume also expands, area expands, and also as well as volume expands, and this is called as thermal expansion. When the body is heated, it expands, which is called as thermal expansion. Application of thermal expansion. Application. A gap is kept. One application is a gap is kept in between two rails. रेल्स में रेल गाड़ी नुहे जो रेल धारणा को रेल्स कह जाए दीटा रेल धारणा भितर किसी किसी गैप रखा जाए कहीं ना जो समर जो अधिक हिट हम से धारणा गुड़ाक जेहेतु लुहार तैयारी सो इट विल एक्सपांड एवं जेहेतु गैप थिले एक्सपांशन हेले दीटा धारणा भितर से जो गैपटा जोड़ी हो मिसीज तेणु आउ रेल तापर गले रेल गाड़ी गले आउ किसी हेनी ना जदि गैप न था हिट जो जो एक्सपांड कर रेलटा आउ रेल गाड़ी गला बेलू डिरेलमेंट हो तेणु डिरेलमेंट नापी गोटे गैप रखा जाए टू रेल भितर रेल लाइन भितर ए गैप इज केप्ट इन बिटवीन टू रेल्स इन समर ड्यू टू एक्सेस हीट rails expand rails माने धारणा ये लिख रेल धारणा and expands and fills the gap thereby avoid derailment of trains. Concrete floors, second point is concrete floors are made in form of gaps of small sections with joints in between विभिन्न सेक्शन करके छोट छोट करके कर दिया जाए और ता भीतर गोटे जॉइंट रखा जाए टू अवॉइड फ्रैक्चर गैप रखार उद्देश्य होची जो हिट हम जो से जो फ्लोर गुड़ा एक्सपांड कले आ फ्रैक्चर हम ना तापर थर्ड वन इज ए कॉर्क स्टॉपर fitted very tightly to the neck of a bottle can be taken out very easily very easily when heated, when the neck is heated. And that is due to expansion of heat. When heat is given to the neck of the bottle, then neck of the bottle expands, but cork is a non-conductor, so it will not expand. So the mouth of the bottle becomes large. So it is easier to take away the this stopper when it is heated. This is all due to expansion of heat. Then I will tell you what is a linear expansion. Linear means one dimensional expansion. When expansion due to heat takes place only along one direction, it is called linear or one dimensional expansion. A long thin rod when heated, its length will increase. Its length will increase compared to its diameter, compared to its diameter. If you take a long rod and thin rod, then its diameter is very small. So if you heat it, then the length of that rod will increase, and the increase in diameter will be very small. That is neglected. So we can call it that this is a linear expansion. Expansion in one direction, one dimension. Let this is called as a linear expansion. This is called as linear or one dimensional expansion. Let because L0 is the length of the rod at 0 degree centigrade. Length of a rod at 0 degree centigrade. And when it is heated and temperature will rise, and at temperature T, then length becomes LT. LT. This is called subscript. T stands for temperature T. Length of the rod at temperature T. This is the length of the rod at temperature 0 degree. So this is the length of the rod at T degree centigrade. That means when the temperature will rise, heat is given, temperature will rise, and the length of the rod will increase. So that means LT will be definitely greater than L0. And then that means LT minus L0, that is the increase in length of the rod. And this increase in length of the rod is directly proportional to the original length. If the original length is small, then increase also will be small. If the original length is large, then increase will be large. So that means the increase in length is directly proportional to the original length of the rod, and it is also directly proportional to temperature difference. So if you mathematical write LT, the increase in length of the rod LT minus L0 is directly proportional to 1 ala is directly proportional to the original length of rod. Original length L0 original माने प्रथमे जोटा थिला प्रथमे थिला L0 तापर हला LT एवं एटा होची LT रो L0 फेडिले दैट इज कॉल्ड एज इंक्रीज इन लेंथ. तेणु ये जो इंक्रीज इन लेंथ टा ओरिजिनल लेंथ ऊपर निर्भर करे डायरेक्टली प्रोपोर्शनल टू ओरिजिनल लेंथ L0 ऑफ द रॉड. Second point is directly proportional to increase in temperature. केते टेम्परेचर बढ़िला ना 0 थिला T हैला T minus 0 is T. Increase in temperature T of the rod T. Then mathematically if you go write this, then LT minus L0 mathematically LT minus L0 is directly proportional to this is directly proportional to sine. Proportional to the original length L0 of the rod is directly proportional to the temperature, increase in temperature. If A is proportional to mathematically A is proportional to B and A is proportional to C, then if you combine this, that becomes A is proportional to BC, or A is equal to some constant into BC. This is a proportionality relation, and A is equal to K into BC. Hello, sir. Hello. Or this you can write as LT minus L0 is equal to some constant. Constant is alpha, is here taken as alpha. This is proportionality constant, directly proportional relation. This is a constant alpha into L0 T, where alpha is a constant of proportionality. Or LT is equal to L0, you can take it to that side alpha L0 T, and this constant of proportionality alpha is called as coefficient of linear expansion. Or that you can common take L0 common 1 plus alpha T. This is your equation 1, you can write it. So LT is equal to L0 into 1 plus alpha T. So if a length of a rod at 0 degree centigrade is given, and you know the value of alpha, temperature coefficient of linear expansion, coefficient of linear expansion, then you can find what will be the length of the rod at temperature T degree centigrade by using this relation. And also we can define alpha as, from this relation, LT minus L0 by L0 T is your alpha. From here also alpha will be equal to the coefficient of linear expansion is equal to LT minus L0 divided by L0 T. That means this is the change in temperature, this is the change in temperature, this is the original temperature, and this is the temperature difference. So alpha, the coefficient of linear expansion, is defined as is defined as the ratio of change in length LT minus L0, ratio of change in length to original length L0 per unit rise in temperature. Iterator ratio এবং per 1/t or per unit rise in temperature. So what will be the unit of alpha? Length is in centimeter, this is in centimeter, so centimeter cancels 1 by degree centigrade. Ki meter by meter cancels 1 by degree centigrade. So the unit of alpha is 1 by degree centigrade. Then expansion in 2 dimensions. This is all regarding linear expansion in 1 dimension. If you take a thin rod, a long rod, then its heating will be on heating. It will expand in length only. So this is 1 dimensional. That is 1 dimensional or linear expansion. Similarly, suppose you take a plain sheet of material. Thickness is very small. So if you heat it, then length and breadth also will increase. So that means area of the area will increase. So that is the expansion in 2 dimensions, or that is called area expansion or superficial expansion. Expansion in 2 dimensions. Or that is called as area expansion, or that is also called as superficial expansion. When expansion due to heat takes place in a plane, it is said to be expansion in 2 dimensions, or area expansion or superficial expansion. And this expansion takes place in a thin sheet of material having some length and breadth. With negligible thickness. And consider a thin sheet of material having area H0 at 0 degree centigrade. This area of this material thin sheet is S0 at 0 degree centigrade. At temperature T degree, if you heat it and its temperature will rise to T degree, so at T degree centigrade, the area will increase, length will increase, breadth will increase, so area will increase. So ST becomes the area of the thin sheet at T degree. ST is the area of the thin sheet. Then change in area of sheet ST minus S0. So this change in area of the sheet ST minus S0 is directly proportional to S0 and is directly proportional to T. So if you write this ST minus S0 is equal to some constant B into S0T. If you combine these two, so that means becomes ST minus S0 is directly proportional to S0T, or that is equal to ST minus S0 is equal to some constant B beta into S0T, where beta is called coefficient of area expansion. Area expansion or superficial expansion, or that gives you that ST is equal to S0 goes to that side. So if you take common S0, then it is called as S0 beta T. This is equation 2. And similarly, here beta is equal to ST minus S0 divided by S0T, or that is coefficient of area expansion is equal to change in area, ratio of change in area to original area per unit rise in temperature. Thank you.